So we found a VGA port. So again, my name is Gary Hlusko. The goal of this talk is supposed to be intermediate. I kind of do a brief overview of a bunch of tools that, as someone who has a bachelor's in economics, I think the programming world and the economics world can bridge together and kind of push programming into the econ world. That's a tiny URL. It leads to a Dropbox with some of my data and also some of the pictures I produced and the codes itself. There's my Twitter, and then there's 2 emails you can reach me at. So it's just tinyurl.com/deltashadows-pi-ohio. So a little bit of introduction about me. I graduated in 2013 with an econ degree. After that, I briefly worked in politics, campaign managing. Depending on your viewpoint of me, I could either be the Frank Underwood or the Jed Bartlett, depending on how you feel. I also learned programming in early 2013 to kind of help automate tasks. And I have a liberal arts degree in economics, so it's kind of the Swiss Army knife, where it's not one great tool as a liberal arts major for one specific thing, but it's a good overall tool. So what is economics? There's a brief disparity between what the people in the outside world view as economics. I've had people ask me, can you do my taxes, which I cannot do. They ask me what stock they should invest in, which I say you shouldn't listen to my advice at all. We're just concerned about the general picture of things. So a lot of people see graphs as economics, which is not necessarily true. We do a lot of data analysis with linear regressions and stuff like that. This particular graph right here is an interesting graph. It's called the Kuznets curve. It's really hotly debated in economics. If you might start a bar fight with it, it's just describing how income over time in relation to inequality is just an upside down U curve. So a little bit of agenda. I'm going to talk about why I chose Python to start with, go over the CSV module, which I think is the most useful place to start, XLRD module, which is more of an Excel-based CSV module, NetworkX, a little bit of data mining, briefly gloss over pandas and NumPy, go over matplotlib, simply, and a little bit of conclusion and take some of your questions. So why Python? Originally, I was going to start with either Java or Python, and I was really confused as a non-CS major about the syntax of Java. So I ended up going with Python because they had simple syntax and also had a already great modules built for the science applications. And another friend actually recommended it. So that's kind of why I started there. A little bit of a disclaimer, I'm kind of self-taught, so some of my code may be a little messy, and it also may irritate you. I'm really sorry. Feel free to send comments or to help me out in the future. So I wanted to start with a CSV module. So in 2012, I was finishing up my senior thesis, which was on the environmental Kuznets curve. And right now, here's a picture of all the data. It's roughly around 10,000 observations with 32 variables. Now, as you can see in the data, there's a lot of holes in it, which means when we start running a linear regression, we have to drop all those because we can't really insert a blank into the linear regression. So what my advisor suggested was we do a 5-year average to kind of smooth out the data. That way there's less holes in the data, and it actually limits the extreme values in some of these variables. So here's a little bit of the code once I get to it. Oh. So my friend actually ended up writing this in Java for me because he saw me in the computer lab at 2 a.m. and kind of felt bad for me. It did it in about 2 hours. Oh, whoops. Sorry about that. So yeah, sure. How do you do the font without a mouse? Anyone know? Control plus. Windows. View. I'm used to using a mouse. Whoops. Whoops. It's my first talk, so I'll remember. I'm sure all of you are texting me like right now, being like, "What's this guy doing? He can't use Zoom." All right.
You're not helping the economists are smarter than computer programmers.
I never said that, to be honest. So I import the CSV. There's a list here which I actually use to break up the list. I like having different modules. So when I do a list function, I just have a list module because it's just easier for me to organize in my head. Basically, because the original data, when I imported it, it was all text, so I added a type integer to check if it's a type. There's probably better ways to do it, but I found this to be the easiest way for me. So basically, we just use a with open. You could use file open or file close, but I like using with better. And then I skipped the original header just so it doesn't get messed up in the data, because if you have any strings at all when you're trying to do averages, it's not going to end up well for you. And then basically just made a iterator to just append all the rows. Now, if you guys notice in the original data, there's a little bit of a problem. Did anyone notice anything about the countries at all? Oh, okay, sorry about that. So if I have a country like the United States, the is actually has a comma in it. So if you're working with a CSV file, it doesn't obviously recognize that. So you're actually saying, oh, there's an extra row here, instead of actually saying, hey, this is actually just all one row. So I had to find a way around that, and the easiest way that I found was actually, I knew how long my rows had to be because I only have a set number of variables. So if it was over that, just add the first row is actually the condensing of the first two, and then just do that till it's the same row. It was kind of a workaround. I don't know if there's a better way. If you know a better way, let me know afterwards. And then the next thing I had to do was transpose the data set, because it's really hard to average down one single row instead of doing it across or down one column instead of across one row. So this data set equals list A is actually just transposing, which I found easier. So I usually try to do checks for myself because I am not confident in my own programming. So I wanted to check how many countries there were to make sure if I was doing 5-year averages, to make sure there isn't an extra year that wouldn't be included in a 5-year average. So basically, what I wanted to do is make a new set. So I broke the array down into items in the set, and this is pretty standard here. So the next thing I had to do was break off the list, and the problem was I wanted to create a list within my giant list of, let's say, GDP. So what I did is actually broke it off into a smaller list so that next time I can just say for item and then average these out. To me, it was easier than trying to do accounting that resets every 5 years. And then I just made basically an average computer that would allow me to compute an average. You can easily change this to do any type of average you want. You just have to replace 5 with an n and just have that part of your call to function, which is kind of nice, but I was in a hurry. So basically what this does is it counts the items that are not blank in the data. So let's say I only have 3 observations in the 5 years, then it's only going to average for 3 years instead of 5, because that's actually a different way to do it. So, and then if there's nothing in the data set for those 5 years, it just prints a null. So this is the part where I just add the countries together. Oh, okay. It's just the part where I add the countries together and just make sure that it just runs the average that I just showed you. So this is a pretty basic example. After this, I just transpose and write it to an actual file using the CSV module. So I think this is actually very useful both in teaching Python and also a reason why economists should love Python because with Stata, SPSS, and eViews, data view or data manipulation itself isn't really as easy as writing 100 lines in Python. This should probably only take a beginning programmer like a night to do, provided they have Google and Stackflow. And then, so I think this is a good way to kind of start out with why Python should be useful to economists. Now, I actually jumped ahead of my talk, so I'm gonna apologize quickly. So like I said, originally, I had basically a night to do this, and my friend saw me in the computer lab, kind of felt bad for me, and he was programming Java at the time. So he did it in about 2 hours, but I didn't really have a lot of time to go through 2,000 data points because at that time Excel doesn't have like just average out this whole list by 5. You have to do a rolling average, which is a little bit different. So in the words of 50 Cent, I got a lot of living to do and I ain't got time to waste. So this is the finished project. I checked a couple, about 20 data points to make sure it was indeed correct. I always try to hand check my data because, again, I don't trust my programming. So with the 182, 187, that's clearly averaged based off 5 years. So this is the XLRD module. And the problem with CSV is if you have a lot of tabs at the bottom, it's not actually, you can only work with one CSV tab file at the same time. Let's say, for instance, in this case, my friend got voting data records on absentee ballots from his county, and they weren't exactly nice to him and just gave them in a PDF. But we have a database where we keep track of this, of people who have requested absentee ballots, so we can send you a mailer or bug you with phone calls till you vote. And so we use XPDF, which is a Python module, to change the PDF by page to actually to an Excel module. Now the problem again is I can only, if I'm iterated to figure out when someone got something, I can't just do that. I can't just download 1,000 pages and do that one for one. So the XLRD module is really nice for going across different sheets. It's similar to the CSV for module, except for it just has a little bit of different syntax that looks a little goofy. So hopefully it's here. Oh, here it is. All right, here is this. I originally wrote this on a Linux system because I dropped my laptop and crashed my Microsoft computer. So it's going to be a little bit different. For instance, the TSV is just a path. Pretty straightforward there. So you have to actually call a book function to open the actual XR or open the actual Excel book, and then just create a sheet function which has the number of sheets, and then which sheet you want to start at. So we obviously want to start at 0 because Python starts at 0 instead of 1. So you just input a simple for sheet in books, and then you look for the actual thing that you want to model. In this case, it was an A for someone someone got an absentee. So basically, this allows us to search within data sets that aren't necessarily organized in one complete sheet. This would be useful, for instance, my friend actually had a Stata data file where she wanted to research based off notes in one of the columns, like if there was a political unrest in the area. So this is actually another way that you could do that with economic data. If you're not actually looking to do data manipulation, but you're looking for certain characteristics in the data, using the XLRD model. But Pandas does give a lot more, does help a lot more and makes it a lot more efficient. So this is the Network X model is actually my favorite module, which how many people were actually in the Mean Girls tutorial? Oh, okay, so quite a few people. So what this data here is the Network X module for the NFL data of from 2002 to 2014. So what I did here is I took all the player rosters for each team, and basically, if two players were on the same team, there's a link in between those two people. Now, this is very zoomed out, and the problem was there's so many data points that Matplotlib actually wasn't very good at plotting this. So I had to save this as a getFi function and then open it up with getFi. But it was kind of fun for me. And then this is actually it zoomed in. So you can see there's a lot going on here, even though the football teams are generally more stable than, let's say, baseball. But you might say, this is me not caring about football. So you're like, Gary, why do I care about football and networks? And to be honest, I don't really care either, except for it's the only data I have. But in economics, we actually look at perfect information. So what this actually means is that everyone across society has the same information, and it's perfect. We all know that down the street, McDonald's is going to have dollar Happy Meals. However, that's not actually true in real life. There's a lot of disinformation, and not everyone has the same information. So today, with the modern standpoint of having social media to look at and using Network X, we can actually simulate and both see what's spreading across a network at the same time, kind of similar to what the NSA probably is doing. So let's say we have a bunch of Twitter data on the Ukrainian crisis of Russian troops coming into the Ukraine. We can actually pull that data and watch how the information flows across both the internet and in real time, which will allow us to study how perfect information affects economics, because at this point, there's not a whole lot that we can study it because of ethical reasons. We can't just say shut down all of Columbus, say, okay, everything's going to remain constant. Now everyone gets $10 an hour wage, and just see how that fares differently than Cleveland. And we can't just throw people on groups of islands and say, oh, this is actually how we're going to study economics. We have to study it indirectly and not in the same way as physics. So Network X I believe, is another reason that economists should learn programming, and another way the programming community can reach out to economics, because as we saw in the Mean Girls tutorial, we can study this in new ways. For instance, in Detroit, when I was working with AmeriCorps, we were looking at how crime is related to other characteristics in the community, and we would actually do a network graph of crime in the area and say who has the most links here. If we wanted to break up, let's say, this cartel, who should we actually target first to actually get the cartel? Because it doesn't make sense to target someone who's not really connected to anyone at all to kind of lower the crime rate. I'm not condoning assassination. So this is a little bit of disclaimer. I'm going to talk a little bit about data mining, and I believe we should do this ethically, and don't hold me liable for anything. And because I've worked in politics, the candidates or any employer now or future may not condone what I'm saying. So data mining is a lot of fun, and I actually use the Scrapey module for this. It's pretty lightweight, and the syntax is relatively easy. It does use a command line to kind of start out the program. And this is basically a 20-line program that will actually go to the Russian Wikipedia and download all the text. Now, that's kind of a very basic example. I've actually mined yellow pages a couple times, and I got banned once because I was overloading their servers. So you have to be careful because some sites obviously do not like you data mining them. For instance, Google will not actually let you just because it messes up their algorithm of what they actually display to you, which is somewhat justified. So just be careful with this. And so basically the way the Scrappy works is you just pull up Scrappy start project, and it just starts. It just creates a new directory for you, and then basically you just use a class of a spider in order to kind of iterate through this. Now I found it easier to use the what's it XML, the XPath, excuse me, for this only because since I can't read CSS. What I do is open up Google Chrome, and if you actually copy it, it'll actually let you copy the XPath, so you don't actually have to be able to read it. It took me a while to figure that out. So there is an XPath module for it. I obviously cannot read XPath, so that's why I use Google Chrome. So that's where the /@ref comes. And so you can actually iterate through almost anything on the web. And you can actually do what we call a spider. So let's say I want to get data from the UN, and because the UN doesn't have the nicest way to download data, I can actually create a spider to iterate through the pages on the UN and get their data so that I don't have to spend 2 hours downloading it. And this also will actually help us in creating more data points for research. So if I want to go through Twitter, create a spider there. And this is an example of, again, the Russian Wikipedia, and this is kind of the output. Actually, I'll just run it. It should work.
Why did you choose the Russian?
I was actually making a module to teach myself to write in Russian. And so to do that, I actually wanted to use the most common words in Russian, obviously, to learn programming. And I went to first Gutenberg project, and the problem with that was that there's only like 3 or 4 Russian books there for you to actually use, so it doesn't really give you a good base. So Wikipedia is actually a very good base for getting general, like the most common words used in the language. So that's actually where I started to use that. So if anyone, Python. Yeah, I even would say C is easier than Russian. But yeah, does anyone have any other questions while we're here? No. All right. So the only bad thing with Scrapey is you can't just start it on its own. You actually have to run it from a directory. Yeah, we will in a second. I have to find the directory name. This is also why you should have good naming protocols, which I'm bad at. Okay. Oh. So you use Scrapey crawl to actually start the project, and you have to go to the directory because when you first start the project, it actually makes its own instances of the spiders. So right now, after it's crawling, it's actually requesting the... It's actually requesting, sending a request to the website. I spelled it wrong, so I don't think it was going to work. It should be working this time. If not, I'll just kill it. This is why I also don't trust myself with live demos. There it goes. So right now it's spit out a bunch of information. So right here, if you look here, This is actually what is known as Unicode. Does everyone know what Unicode is? Okay, good. So so obviously I can't print in Russian characters. So what you're looking at right now is basically the Unicode of the Russian characters, which is actually was the main problem with making my own like Russian typing program, because the Unicode was actually the most annoying part because there's no way to do that quickly. You just have to actually hard program that.
If that's a repr, of course, you will see the stuff like you see there. If you just do an str of it, at least within the Linux world, you will see your Russian just fine.
Oh, okay. Yeah, I should have mentioned that. This is the Windows. This is the.
So I realize that might have been the issue. I don't know if it's because you're doing a repr or because of your host OS being Windows.
Yeah, I think it's a little bit of both, but it's definitely because of Windows too, because I can't just print on. I just can't print it just by itself in the unit or in the idle, so to speak. So So basically, I think data mining can be extremely useful in both gathering data. I actually had a Reddit one, but my other computer fried, so it actually would print out the front page of Reddit too. But again, be careful with using it, and also make sure you use a sleep variable, because when you don't have a sleep, it's going to go like 20,000 iterations in less than a second. So not only will you actually backlog their servers, but you'll also get caught pretty fast. Yeah, I actually, if you,
So when you ran that, did you come up with a list of the top 10, or what were the results of your data mining?
so I actually did two things. Not only was I looking for the top 10 words, but I also was looking for the top characters used, because originally I start with one character. Excuse me. So yes, I did find that. I don't remember what they are off the top of my head. There is a list somewhere buried in my computer. So. So the next part, I'm just going to really, really gloss over, because it seems like half of Pi Ohio is about pandas, NumPy, and IPython, which I love these programs. I'll show you why in a second. But from an economic perspective, it's really easy to work with this than the Stata and the SPS syntax, because this is almost, to me, it's a lot similar to the SQL syntax, which is a lot easier than Stata, because oftentimes you have to put periods in Stata that I don't even know where they're at right now. In fact, in my actual original code, there's a Stata file there of doing a similar project in Stata. So let me pull this up. So just to give you I have to do data tests every so often for a politics job if I want to work in the data field. So this is not using NumPy at all to actually complete one of these data tests, and they're generally the same. It's saying, oh, how many duplicates there are, how many people have this characteristic. So just using the CSV module and using also datetime to parse dates, which is not very fun at all. We're talking about like over 100 lines here, and this is for a very simple one. So for instance, a pandas module, which I absolutely love now, we're talking about the same data test with a lot of white space. That's 39. 39 lines, which from an economic perspective, your time is very, very valuable. So the Pandas allows you to do a lot of cool things. It's very efficient, and it's a lot easier to use than CSV for at least this type of work. So it also allows you to do a lot of output that you can just save right away, and you can do a from CSV into to CSV. So it's highly efficient and very good at doing the type of work that data analysis that economists would use, or even poli-sci majors, or a lot of the social science. So that's just a quick example. Again, half of PyOhio has been about pandas, which a lot of people can explain better than me, so I'll just leave it there. So very efficient SQL-like syntax and operations, and NumPy allows you to do matrix operations too. So matplotlib is really nice to play with. So this is a isoquant or a contour. So the production function briefly explains why there's a difference in payments overall in the whole economy between the labor force and the capital force, the capital being the people like CEOs and people who own actually the parts that run the business. So this is a three-dimensional plot of of the starting points for each function, and then draws the function with each line. Now, if you've taken calculus, it's a polynomial function, so it's completely continuous. So basically, these lines actually could be a shaded grid and kind of make a period-like object. So this actually is pretty useful because it's only about 40 lines to do this in Python, and just allows some great graphical interfaces. And this is a very poorly drawn Python matplotlib map. I've seen a lot better ones. So this is just the basics of what you can do. And you're not going to get this type of output or this much control in a stata function or SPS or eviews. So the last part I want to talk about, which I think is actually the most interesting from my perspective, is actually SymPy, which is not SYMPy. This is simulation pi. So what this allows us to do is run simulations within Python. It's a very complicated library, and there's two types of libraries. There's the SymPy 3.0, and then there's the SymPy 2b. I used the SymPy 2b because the documentation was slightly better. So the first economic question is kind of dealing with traffic and why it kind of gets congested. So we can actually use this to study economic modules in a way that's somewhat more realistic as far as complexity science goes. So we can allow just different agents to interact with each other and see what the overall effect is. It's kind of like the ogre game that was actually in this room yesterday, where we can just keep iterating and see what the overall consensus of our modules are. And here, I'm hoping this actually runs. I actually made a supply-demand module, and I'll pull up the code real quick. So basically what I wanted, is this it? Okay, this is it. So basically what I want to do is just make a really basic module between buyers and sellers in a very, very simple demand market. So the buyers actually get their own budget, so to speak. Sellers get their own price. Buyers go to a seller. If they can't pay for the item, they go to another seller. So basically the best way I found, and again, this is a very basic example, is using just the class seller or class buyer with a sim process. The sim process already kind of uploads the whole back part, so you kind of just have to make the actual characteristics of each buyer in this case, or each process and resource. So a process is basically your agent, the resource is what they're trying to get. So in the case of filling up a gas tank, the car is a process, the resource would be the gas tank with a fuel. So again, this code's online, so feel free to look at it and critique it as much as you want. Basically, the biggest things you just have to do is activate the buyer. So this actually adds a queue for it, and then actually run the simulation, and it runs until max time. You can have it based off actual events. So hopefully this actual live demo works. So the first output we should see is actually the activation going on. It runs a little slow. I use idle just because when I'm testing things, it's a lot easier, because out of my paranoia, I just keep restarting the shell just to make sure the memory is not saved there. Because I've had problems before with a function actually that I change and have it actually, it's still in the memory, so it messes up the function. So should have started this first. So what you, so like I said, this is actually activating it and putting in the queue, and then I have it print out buyer 1 and seller 4 negotiating, and then if it's sold at 8. So I can actually use this to graph the function. I haven't done this yet because the simulation is makes a lot of assumptions. So the question is, does each buyer have their own demand curve? So the buyer itself, like, so an individual buyer is just a line on the demand curve. So in essence, you're just saying, oh, this buyer has 15, and then the actual demand and supply intersection comes from the seller actually negotiated with it. This is actually called a pip market simulation. So how many people have taken an econ class? Did you guys actually play the game where half the people get black cards, half the people get red cards? Those are your seller price and your buyer price. So you go around the room, and let's say I have a seller card of 6. I'm looking for a buyer that has over 6 budget to work with. We agree on the price, we write it on the board. Actually, if you play this enough, you'll actually see the market go towards a 6, which is the equilibrium value at that point. So yes, they each have their own demand curve, but it's not necessarily a curve, it's a point in this respect. Good question. So I think we could use SymPy even to run very basic interactions with people to help drive not only some model testing, but to change economics more like an experimental physics. In a sense, we're kind of looking at, oh, does our model actually fit the real world data? In SymPy, you can use real world data to kind of start things off. So conclusion, programming can help economists manipulate data. We could do a lot more experimentation with us to kind of test the module field, or excuse me, models field. And we can test the underlying assumptions in economics and kind of see what's going on in the big picture. So comments, concerns, conclusions, or excuse me, questions, comments, concerns.
I have a question, perhaps not strictly Python related, but more economist related. How do you handle cases where you're trying to look at like a group or a population? Like you've got data, you're trying to determine certain things about a group. You don't really know how large the group is. How do you determine how large of a sample to use to feed into something like this?
So basically, that's actually a pretty complicated question, because one of the problems with economics is when you look at a data, you can't really compare 1919 data with 2012. So overall in the data, we just make assumptions about sampling. It's one of the biggest problems in economics because we don't really get the best sampling in the same way that physics does, or biology or chemistry. So it's more a lot like psychology, where you're kind of like, in the overall sum of things, the more we do it, the differences between the whole community will actually even out. So on a micro level, there might be a lot of error, but overall in the macro level, you actually have an overall motif going on. So it's kind of like, I just got into complexity science, so looking at the movement of animals or birds in the swarm to see exactly where the flock's going, so to speak.
So have you found any real world applications for your supply and demand simulator?
Well, considering I just made it, not at the moment, but what we can actually do is look at, I'll give you an example of a mathematical application. So the FCC, when they first were made, Al Gore actually talked to some mathematical people to figure out the best way, so to speak, to use game theory to sell off basically radio rights or what have you in the country. Australia did a similar thing, except for they just did one actual sell, and you had people paying billions of dollars for some market and literally someone paying $1 for another. So they actually used some mathematical, not exactly in simulation in this sense, but mathematical game theory to actually make sure that the rights of the FCC were giving out, that they were actually sold at a fair market price. So you can use it to see not necessarily the best way to do things, but also just if our models are correct.
Realizing this is a Python conference, so you picked Python, but did you look at other languages such as R or SAS or things like that? And within Python, have you ever used that to get to some of the R modules?
There actually is a Python module for both R and Stata, and I want to say SPSS, but don't quote me on that. So yes, you can actually bridge into those. In fact, I believe R, its syntax was actually based off Python. So yes, you can actually use Python to manipulate.
When you were looking at it, you pretty well decided on Python right away because that's what the tools that you had.
Well, it was also for the fact I wanted to learn programming per se. So like, if you learn SPSS or what have you, you're kind of very limited by just data analysis. Whereas Python, you get the choice of having data analysis, but you also get to do cool things like data mine and run simulations that I believe you can't do in R, and I'm almost certain you can't do in SAS. And if you can, it takes a lot more.
Yeah, I think the statistical routines are much more developed in R than they are in Python. But for your analysis, it's probably correct.
Yeah, and I mean, I think that's one niche that Python can fit into the econ world. It's not necessarily data analysis in forms of regressions or tests and stuff like that, but more of the research realm.
Okay. For the simulations you're running, basically, how many variables could you put in? How complicated could you make the model?
Without a memory error, or so that's one of the problems with Python is obviously the memory error. And I chose for this one to be between 15 and 100 just to kind of even it out. I was trying to go, I think when I first ran it, up to like 10,000 just to do it. But I ran into a memory error, which also might be just the way I'm using the classes is not necessarily the best, and you can definitely lower the memory. All right.
I studied international relations, so I was just wondering how did you run into any trouble data mining the UN website?
It's not. I haven't tried data mining it, but
okay.
as you probably know, it's not very friendly. In fact,
No.
for those of you who don't know, let's say you want to get GDP off the UN data site. First off, you have to. It's not like you could just go like the U.S. Census Bureau and be like, I want GDP of every country. You have to go find the variable through a very long dropdown, and then you can only download one country at a time. And I believe you have to actually physically click all the years. So it's a very time-consuming process. So I think you can because Scrapey also lets you do headers, and that's actually how I got around Yellow Pages is because you could tell it which header to actually click.
So with Scrapey, you would be able to kind of put together a program to data mine the UN website.
You should be able to, but again, I'm not condoning it.
Have you ever thought of looking at the CIA World Factbook? Because they usually list all that.
The only
in
problem with
up to
that
date.
is they
Yeah.
only list, I believe, the actual year. So I believe
Yeah.
it's the
So, I
actual
mean-
current year. We actually do use that data to look at trade agreements because
Okay.
they'll actually list trade agreements. But yeah, I believe it only lists that year the last time I checked. Well, thanks for having me, guys.